This video will help you complete the bowling ball in the hallway graphing motion assignment. So here we are at our week 10 folder. This is D periods, so that's Monday, Wednesday this week. And if you're an F period, it's only Tuesday, but the process is the same. In your Monday folder, if you're D period, in your Tuesday folder, if you're F period, you're going to find our agenda and a bowling ball video. Right, so bowling ball and hallway. That is literally just a video of a bowling ball going down a hallway, and I've marked up the hallway with pieces of blue tape every 5 meters, up to 25 meters. You're going to time the bowling ball. How long it takes to go 5 meters, how long it takes to go 10 meters, how long it takes to go 15 meters, 20, and 25 meters. You're going to get time values for each of those, and you're going to just record that in here, data, linear motion in the hallway. Right? So let me model it. I'm going to use fictitious numbers so that you can generate your own graphs with real numbers here. But you just launch this video. Right, so you get the video going, and there's the bowling ball, and it goes down. You start the watch there, and that's the 5 meter mark. Let's pretend that, excuse me, sorry, get that out of here. Let's pretend that you don't start at the top of the ramp. You start right there on the floor to there. That's 5 meters. Let's pretend that took, I don't know, let's pretend I had my watch out and that took 4 seconds. Okay. Well, then I go back to here and I go to this week's submissions, and 5 meters took 4 seconds. And again, I'm pretending. That's not the real number, right? So 0 meters is 0 seconds. Maybe 5 meters took 4 seconds. Okay. Then let's say I went back to the ball, right? I went back to the video of the ball, and I timed it to the 10 meter mark and the 15 meter mark, and I get these numbers. Maybe pretend it's perfect. And that one took 8 seconds. And the next one maybe took, maybe the next one took 12 seconds. And again, I'm just making these numbers up. And maybe the next one took 16 seconds. And if so, perhaps the final one would take maybe 20 seconds, right? If this were the case, it's going 5 meters in 4 seconds, and then 5 more meters in 4 more seconds, right? So in each interval, in my fictitious example, each interval is 4 seconds to go 5 more meters, okay? So that's it. That's for the data, right? Then what you do is you graph this, right? Sometimes when I have some data I want to graph, I just grab a little screenshot of it so I can have it hanging out somewhere where it's easy to see, right? Because I've got to go back to here and the submissions folder, and I've got to graph that ball's motion. So here's the graph. It's a blank graph, and all I do is I graph what I just collected. So let me get this up. You might not be able to see my data because I think I'm just recording the Chrome. Actually, it looks like I'm recording part of the screen itself. So I believe that you can see that actually. And in any respect, so there's the 0, 0 there. Let me move this over a bit so that I can get to my drawing tools here. Okay. So here's a tool that you're going to use for this, right? So I would just do this. I'd just make a little scribble. Where? Well, 5 meters took 4 seconds. So the distance goes on the y-axis, and the time is on the x-axis. So in 4 seconds, it went 5 meters. I'm just going to make a little scribble right there. Okay, and then the tool switches to that one. So I've got to go back and choose the scribble tool again. Right, and so and 10 meters, maybe it was 8 seconds. So I'll go to the 10 meters, and that took 8 seconds. Right? So I'm just being kind of quick about this. Maybe not very accurate, right? But something like that. And 15 meters took 12 seconds. And 15 meters took, there's the 12, 15 right there, I think. Again, I'm just being kind of quick and messy about it. And what was that? That was the 15 meter mark. So 20 meters was 16 seconds. Oh, this only goes to about here. That's okay though. So your real numbers will be less than this, right? So 16 seconds, I have at 20 meters, and I'm going to stop here. That's about there. Right? So those are my dots. I just want to switch this over to the straight line tool and just go like this and draw a best fit line, but not like that. Draw a best fit line here, and that's really close. Now that line's going to be a little bit hard to see. It's gray and it's very fine, so make it thicker and make it a different color too. And I don't care what color, just make it easy to see. Right? And there it is. That's a graph of a bowling ball taking 4 seconds to go 5 meters, taking 8 seconds to go 10 meters, taking 12 seconds to go 15 meters, and taking 16 seconds to go 20 meters. And that's it. And then go to the next slide and say replace, and it says replace this text with a description of the motion of the bowling ball in the hallway. What does your data and graph show? Well, I don't know. What does it show? It shows my graph, because it was so idealized. Oops. My graph, because it was so idealized, shows perfectly constant linear motion. Right? The slope of the line, as we just learned, is the speed of the object. And that slope is very consistent. So the speed is very consistent. And it shows a constant, 5 meters in 4 seconds. That's 5/4 of a meter per second. That's 1.25 meters a second. The slope of this line is 1.25, and that slope represents the speed. Okay, great. Go get it done. Don't use my numbers. I made them up. All right, have a good day. Thanks. Bye.